The next lesson in this chapter is talking about two other main factors that can affect enzyme catalyzed reactions. And these two factors are substrate concentration and enzyme concentration. As we are getting into this lesson 7, we will now see how these two factors now bring about changes in enzyme catalyzed reaction. So we start with the third factor, which is the enzyme concentration. In this case, we are going to see how the concentration of enzyme can bring changes. We are going to see how low concentrations or high concentration of enzyme can bring about changes with respect to the substrate. The rate of an enzyme catalyzed reaction is directly proportional to the concentration of the enzyme present, as long as no other factors are limiting the rate of the reaction. So, in the case of enzyme concentration, we are emphasizing that the rate of enzyme catalyzed reaction is directly proportional to the concentration of the enzyme present, in as much as there is no other factor that can limit that rate, because you have other factors like temperature, pH, and substrate concentration, and other factors that we mentioned at the beginning. So, for you to analyze this, all the other factors must be kept constant in order not to affect this. In this case, the substrate concentration is maintained at a high level, and the pH, temperature, pressure are all kept constant under these conditions. As the enzyme concentration is increased, more active sites are available. The rate of enzyme reaction also increases. So it is good for us to understand this, that under these conditions, as the enzyme concentration is increased, more active sites are made available, and the rate of reaction also increases. Because since we are trying to see how enzyme concentration can affect a reaction, we now said that the substrate concentration is kept so high, and the enzyme concentration is the one that we shall be playing with it. Because we will realize that if we have, for instance, if we have maybe 10 substrates in the medium, and we have 5 enzymes, active sites, we now see that these 5 sites will be occupied by the substrate. And if we increase the number of sites of the enzyme, the reaction will continue because more substrate will bind now to the free active sites. Therefore, when we increase the concentration of the enzyme, the reaction continues until all the active sites are occupied. And when all the active sites are occupied, the reaction stops. And when all the active sites are occupied and no substrate is found in the medium any longer, even if we increase the concentration of the enzyme, the reaction will not continue because there will be no substrate to bind on the active site. When we look at these two graphs, we now have the first one that shows the rate of reaction and the enzyme concentration. The second one that shows that at a certain point in time, the active site now became limited, and that's why the graph flattened. Now, let's go to the first graph, which has a straight line increasing upward. In this case of this first graph, there is excess substrate. The excess substrate, the rate of the reaction continues to rise because we have excess substrate in the first graph, in graph 1, and more enzyme. So the reaction now continues because there is excess substrate and free sites for the substrate to bind on the active site. That's why the reaction continues. It is good for us to understand that very well. In the second graph, we now realize that the graph flattens after some time. This shows that the amount of substrate now became limited. Then the graph tails off. Now, since the substrate now became limited, there were no substrate now to bind on the active site for the reaction to continue. It means that in this medium, we may have more enzyme. In other words, the concentration of enzyme may be too high, but the concentration of substrate is low. So in this case now, no matter how much you increase the enzyme concentration, no reaction will occur. No reaction will occur because the substrate now is limited. The amount of substrate is limited. No matter how much you increase the concentration of the enzyme, there will be no reaction. Now, this takes us now to the next factor, which is the last main factor, and which is the substrate concentration. For a given amount of enzyme, the rate of an enzyme catalyzed reaction increases with an increased substrate concentration up to a point, that is the Vmax, when any further increase in substrate concentration produces no significant change in the rate of reaction. What are we talking about here? Here we are trying to analyze substrate concentration. We now take a medium in which we inject enzymes with the active sites. So you now realize that reaction will take place, and if all the substrates have been used, the reaction will stop. And if you increase the substrate and there are still active sites, the reaction will continue. And that's why we say that the enzyme catalyzed reaction increases with an increase in substrate concentration. Because if the active sites are available and the concentration of the substrate is low, the reaction will stop. But as soon as you increase the substrate concentration, the reaction now will continue in as much as the active sites are available. This is because at high substrate concentrations, the active sites of the enzyme molecules of any given amount are virtually saturated with the substrate. Therefore, any extra substrate has to wait until the enzyme substrate complex has released the product before it may enter the active site of the enzyme. This is again very important. We are trying to say at this point that if you take, for instance, 10 enzymes and in it you inject 5 substrates, that is, you have 10 enzymes active sites and in which you introduce 5 substrates, you will realize that the 5 substrates will now bind to the 5 active sites of the enzyme, and 5 active sites will be free. If you add 10 substrates, you will realize that the other 5 active sites will also be occupied. Therefore, at some point in time, all the active sites of the enzyme must have been occupied by the 10 substrates. That is the 5 first substrate plus the 5 other substrates that were added. All the active sites have been occupied by the 10 substrates. In this case, if you add 5 more substrates, making it to 15, there will be no active sites for the 5 extra substrates to bind to. Therefore, an enzyme substrate complex must have been formed. It is only when this enzyme substrate complex will leave the active site, when the enzyme substrate product must have been formed, that some free sites now will be available on the enzyme for the 5 extra substrate to bind to them. By so doing, the reaction will continue, without which the reaction will not continue. Now, when we look at these graphs, they are there now to give more clarifications on what we have been talking about, substrate concentration. Now, if you look at the first graph, you now see that the graph rises and tails off or flattens. It means that at some point in time, all the sites, active sites of the enzyme were occupied and the excess substrate could not bind. That made the reaction to flatten or the graph to tail off. The second graph still explains the same thing, talking about the effect of substrate concentration on the rate of enzyme action. The graph still flattens because the concentration of the substrate now was not that could fit to all the active sites. The third graph still explains the same thing, and the fourth graph explains the same thing. All these are just to explain or show how substrate concentration can affect enzyme activity. These graphs we have here still explain the same thing. So you now see at the first one that at point X, the graph flattens or tails off. Here it is saying that increasing concentration does not affect rate of reaction. It means that no matter how much you increase the substrate concentration, there will be no reaction because all the active sites of the enzyme must have been occupied. So no matter the amount of substrate injected, there will be no reaction, and that's why the graph flattens there. The second graph now explains the same thing with substrate concentration. You now see that just at the beginning here, increased substrate concentration leads to increased reaction rate. You now see that as the reaction is increasing, or as the concentration of the substrate is increasing, the reaction is increasing until at the point where all the active sites now have been occupied and the graph tails off or flattens. And at this point, all enzymes present are working at maximum rate. And that is explained by the last graph which you have there, still explaining the same thing. All these graphs are just there now to make you understand exactly what we are talking about, substrate concentration. I hope you did enjoy it, and I hope you go back and go over this same lesson, go over and over so that you understand exactly the basics that are found in these factors that affect enzyme catalyzed reactions. Thank you very much again for your kind attention while we prepare ourselves for the next lessons of this particular chapter. Do not forget that this is the Greens Academy, bringing all these lessons to you for you to improve in your knowledge and capacity of understanding. Thank you.